If an artificial intelligence has the power to fix a production server, it holds the exact same power to destroy it. The industry standard right now leans toward a dangerous anti-pattern, giving large language models direct API keys or broad terminal access so they can troubleshoot on the fly. Relying on the internal judgment of a probabilistic model violates the core rules of deterministic security. You cannot mathematically prove what an LLM will decide to type next. The ultimate failure point in this setup is granting an AI direct connection to a Docker daemon, the docker.sock file. Give a hallucinating model socket access, and it can wipe out your entire host system. Autonomous systems require a separation between the reasoning engine and the execution environment. The component that identifies a problem cannot hold the rights to modify the infrastructure. This brings us to the NoPager architecture, a clean, segmented approach to AI operations designed around zero trust. It operates on the principle of least agency. While least privilege limits what a user can access, least agency limits what an automated system can represent and execute. To achieve least agency, you must build a hard-coded deterministic boundary, a physical separation in the architecture that the AI lacks the capability to bypass. Safety depends on architecting a system with a restricted blast radius, regardless of the intelligence of the underlying model. To build this boundary, we start at the beginning of an incident. An AI should not be continuously monitoring your systems and burning tokens 24/7. It must be incident-triggered. The trigger itself has to be a deterministic external measurement of your system's health, completely independent of the AI. This YAML uses a health check block running PG is ready. If it stops, health drops. After exactly 3 consecutive failures, it opens an incident. The system aggressively redacts secrets before evidence ever reaches the isolated AI worker. This worker node exists under strict confinement. It has no Docker CLI installed and absolutely 0 socket mounts. The worker is only allowed to output a typed JSON proposal. Furthermore, that proposal must be selected from a hard-coded, pre-approved catalog of specific actions. By strictly bounding the input evidence and severely restricting the output format, the system neutralizes erratic behavior. Even if the AI hallucinates wildly, it can only ever suggest a pre-approved, cataloged action. It cannot invent a malicious one. Suggesting an action is not the same as executing it. There is a physical architectural gap between the isolated AI worker and the privileged host helper that actually controls the server. The only way across this gap is through a narrow Unix socket bridge. When the worker sends its JSON proposal, the helper intercepts it. It uses the Linux SO protocol to verify the exact user ID making the request. Next, the helper authenticates a specific local protocol credential. If the UID or the credential has been altered in any way, the request is immediately dropped. These dual checks strip the AI of any inherent power. Its authority is reduced to a single, tightly controlled permission, the ability to submit a formatted request. Once the origin is authenticated, the system transitions to the execution phase by rigorously validating the target of the proposed action. The helper securely maintains an immutable list of approved targets. The incoming request must rigidly match this list. The helper confirms the Docker container ID and compose project, explicitly blocking any attempt to mutate the control plane. In distributed systems, a single incident might generate duplicate or overlapping mutation requests that arrive at the exact same time. To handle this concurrency, the helper generates a durable universally unique identifier, or UUID, for the specific approved action. This UUID enforces idempotency. Even if 3 identical restart requests hit the socket simultaneously, the helper locks the UUID, ensuring they result in one and only one system mutation. Because this entire security boundary exists completely outside the AI's logic, malicious prompts or internal reasoning failures are rendered entirely harmless at the execution layer. Execution, however, is rarely perfect. Operational reality dictates that systems can crash, time out, or halt mid-mutation. When an action is interrupted, a corrupted execution log or an incomplete process must never trigger an automated, blind retry. Guessing what happened next is how cascading failures start. This introduces the ambiguous state. If the historical knowledge of an event is undetermined, meaning the system cannot mathematically prove what just happened to the server, it must immediately lock down. The only safe resolution for an ambiguous state is human escalation. The system logs the uncertainty and pages a real operator. But what if the execution completes successfully? The process still isn't finished until the recovery is verified. The AI worker that requested the mutation cannot be trusted to verify its own success. A compromised or hallucinating node will simply report that everything is fine. This draws a parallel to Playwright's UI testing, where developers use Axe Builder to verify specific DOM elements independently. NoPager mimics this exact logic. It uses external HTTP health checks and container state validations to confirm the target actually recovered. Operating an autonomous system requires accepting that automation is inherently blind to its own actions. Operational trust can only be established through independent, isolated probes that observe the final outcome. The core lesson of AI operations is that security relies entirely on system architecture, not on clever prompt engineering or the underlying intelligence of the model. We secure the environment by distributing the verbs. In the first half of the sequence, the AI model proposes a solution, and then the deterministic policy decides if it is allowed. In the second half, the privileged helper executes the action, and finally, an external probe verifies the result. By enforcing this strict separation of powers, the architecture successfully contains the blast radius of any compromised component. The authority to restart a production service is brief and ephemeral. It is often just a 3-second window of vulnerability where a system mutation actually occurs. That brief window of authority requires an uncompromising, verifiable chain of trust to remain safe. We do not grant trust to the AI. Instead, we build a deterministic system that renders the AI's flaws irrelevant to the survival of the production environment.